It's space weather. All Earth's weather comes from space. The space weather might just be raining on your face. Looking at the sun on 304 angstroms. Got an active region rising. Not to be confused with a sunspot. We've got filament activity. Plasma filaments dancing around all around the limbs. This looks like especially the southwest. Let that play through also. And the most significant thing that I've noticed is a solar crown prominence. Solar crown prominences are associated with high levels of solar activity. You're going to see one right here when this plays through. Right there at the beginning. Did you see that? It was right at that location. Let it play through one more time. Solar crown prominence. A feature we have not seen in quite a while. Let's see if that prominence is noticeable also on the 171 angstroms view. Would be right near the beginning. Looked like only a little bit of small magnetism. All right. We've got some magnetic looping in the northeast. And let's get a look at that very large active region. And it looks like another active region is following it also. Let that play through. Take a look at the edge of the disk in 171. And here are your magnetic lines in 94 angstroms. By the way, that's anomalous data there. Not exactly sure why that happens, but we do occasionally see it. Quite sure the magnetic fields are not quite oriented that way. Moving on. And let's look at the real-time solar wind. We see the BTBZ is kind of returning to the zero line, at least the angle portion of it. Phi angle is a bit of an ongoing signal around 315, but no recent significant connections there. Solar wind density 5.17 protons per cubic centimeter. Solar wind speed 352 kilometers per second. Small uptick from yesterday, but still quite weak activity. Let's head to spaceweathernews.com for a data rundown. Tiny little increase in X-ray flux there. Nothing even approaching anywhere close to the B range, so no solar flaring. Now we do see some wild spikes in the BTBZ. Keep in mind this is not as recent. That just started early this morning, but it looks like it has converged since then. We do see the phi angle bouncing around in the past couple of days. We would be expecting a magnetic connection with that coronal hole, and this looks like it's a beginning sputtering connection there. And you can see we do have an uptick in the solar wind speed, but not high enough to really do much significant. Magnetometer is looking pretty normal there. A fairly smooth and normal range. KP index is back to 0, and we will be looking at cosmic rays. We are expecting to cross the heliospheric current sheet anytime, if not already. And there is your Cygnet's forecast. Keep in mind this is starting on the 23rd and extending through through New Year's, through January 1st. So there's your prediction of what's going on. Also note, this view also does show the Parker probe. It shows Mercury, Venus, Earth, Mars, Spitzer, Osiris, etc. And let's look at the cosmic ray situation, as there were some spikes. Now, yesterday, Ulu actually returned the highest cosmic ray spike it's seen since December 3rd, it looks like. However, it has calmed down in Oulu. Sorry, I mispronounced it again. Oulu, Finland. Greece more recently had a big spike in cosmic ray. You can see there at the Athens neutron monitor. And that is indeed also the highest we've seen there since December 2nd or 3rd. Mexico City not really in agreement with that, although there was a spike early on Christmas there as well as the other monitors. And the last cosmic ray monitor we'll look at, Moscow, not really increasing with the others there, so let's just disregard that for now. Looking at the magnetohydrodynamics here, here's your magnetosphere, and first looking at velocity, we can see the highest velocity zones are in the magnetotail and opposite the poles in these areas. This should give us some idea of when the Earth crosses the heliospheric current sheet. Let's look at the density. All right, so you see the density as this builds back here. That could indicate the shift in the heliospheric current sheet. Also, you do see a bubble come out of this area. Little density bubble, we'll let that play through again. Right there. No. Wait for it. There it goes, little density bubble comes out. And let's look at the pressure. This one's probably the most telling of all. You can see this area of increased density over here. And it looks like a change in the orientation of the incoming plasma is occurring. And let's take a quick look at solarham.net. We'll leave links for that also. Great source for solar data. They put the magnetosphere right on their homepage. The solar magnetogram, that is. And there's your incoming plage. Big fields associated with it, but no umbra. As we will show you, no sunspot, only penumbra. Now we'll leave a link to this article here. This is from February 2014, forecasting the maxima of cycle 24. Well, the reason that we were talking about crown prominences is because crown prominences have to do with solar maximum. Obviously, we're nowhere near solar maximum. However, any crown prominences are something significant, We will leave links to the article. Rush to the Poles. Not to be confused with Rush the band. Next, we will link to another article here about the sunspot cycle. This one's from 2017. This is for our less advanced viewers, perhaps. It's going to explain how sunspot cycles are calculated and so on. The historic analysis of sunspots, the Maunder minimum, the butterfly diagram, all explained. Sunspot cycle predictions. And they're not going to talk about Valentina Zarkova here. Next, we would love to refer you to electroverse.net. Published an article on November 6th regarding Professor Valentina Zarkova breaking her silence and confirming the new super grand solar minimum. Now, Valentina Zarkova, she studies the internal magnetic dynamos of the sun, and she's more concerned about things like crop loss than she is global warming, since the globe's not warming. Also, she is aware that carbon dioxide is not, nor was it ever, a greenhouse gas. The new minimum should be named for 1970s Jack Eddy, who was instrumental in drawing attention to the existence of the Maunder minimum and its effect on terrestrial climate. Cosmic rays, they cause cloud nucleation. Cloud nucleation causes an increased albedo on our planet. Increased albedo causes more infrared radiation to get bounced back into space. More infrared radiation getting bounced back into space makes your planet colder. It's all because of the sun and its magnetic fields especially. Let us just reiterate how magnetic fields run the universe. Speaking of magnetic fields, Saturn has a huge one, and it's just about at Earth opposition. There's your map of the planets today. Let's advance it for you so you see what will happen in the near future. There's 20 days of the solar system. We will leave links to that also. Also, in our constant quest for more data, we found another spot where you can get massive amounts of that government data that you desire so much. So we'll leave a link here, and it's a lot of data. Help us go through it. This does give you the ability to make yourself custom screens, and I want to try it out on the computer, see if I can make myself a custom screen, and then I'll just be able to load it, provide links to it, and show you the exact information that we want to show you all on one screen, help you out looking at it on your own. Hey, thanks for tuning in, everybody. We're going to close it out by looking at the 304 angstroms view. Let me bring your attention once again to the crown prominence that comes out right here. There it is. I got the arrow a little too far to the left. It's actually here. Let that play through one more time. Now remember, on your way to understanding the significance of crown prominences, don't drink. And if you drink, don't drive. In fact, don't drive, period, and drink if you want to, and understand the sun and solar prominences. Also, thanks subscribers. Please don't forget to press that subscribe and like button if you have not already done so, as we are trying our best to get to 1,000 subscribers. Will it happen before New Year? We doubt it, but stay tuned. There shall be more.